Bible for any spectrochemical analysis. So, ayan ako muna yung background natin para makita nyo. So, yung lesson natin maybe for the first month, mostly about this book. So, yung lahat na nakaano ko, ginagawa ko pa lang. So, today we will do spectrochemical information. I'm not sure if you can, siguro, i-ano ko muna yung sarili ko. Stop share. Okay, and then in. Okay, so ang mangyari spectrochemical information and then spectrochemical measurements. So, maganda yung ano siya, niya, based doon sa mga nabasa ko. So, ito yung ano natin. Tapos yung isa pa, yung introduction to spectroscopy. Okay? And this was by Pavia, but when I read it, mostly pang ano siya yung, alam niyo yung Chem 115? Mostly meron siyang in terms ng mga particle of the box. So I said, hindi ko ata porte to. So I'm just going to pick up some that is related to our lesson dito sa Pavia na to. Because yan yung parang Bible that they have in spectrochemical analysis. Okay? And I'm starting to come up with the question. Okay? Doon sa, siguro based nga sa dami na ano natin, we will have a midterm and a final. But I'm going to give to you all information well ahead. So I'm hoping that maybe next meeting, okay, ibibigay ko na sa inyo. Okay? So we're going to talk based on Engel and Crouch. Yung first ano nila, yung tinatawag natin spectrochemical information. Okay? So meron akong nakalagay dito mga terms. So usually we have what? Spectrochemical analysis, spectroscopy, at yung tinatawag na spectrometry. Okay? So siguro ang gagawin natin, mag-interact tayo, ano yung sa pagkakaintindi nyo, yung bawat term na to. Okay? So maybe we go on this one. So maybe the main description that I can put here, okay, is it's one of the major tools in analytical chemistry. Okay, so chromatography is more on separation, but okay, nandoon pa rin sa ibang chromatographic techniques yung spectrochem in the form of the detector. I'm not sure if you're familiar doon sa detector, okay, that we have discussed. So nandoon pa rin yung spectrochemical analysis. But if we're going to look at this term, sa tingin nyo nanggaling to? Yung word na spectrochemical. Anyone? Ano usually nakikita nyo pag meron kayong data ng spectrochemical analysis? Anyone? Meron kayong... Ha?
Absorbance.
Meron kayong either spectrum or spectra. Now, the other words is we could say chemical. So we could say spectrochemical is just a compound word that comes from spectrum kapag isa, spectra kapag madami. So ano ba yung makikita natin sa spectrum? So,
Color, sir.
color? Well, we could say it depends, right? Kasi yung spectrum kasi, if we look at our introduction last time, it could be what? It's just a display of intensity. So anong intensity ang pwede nating makita? So pwede natin sabihin yung radiation na na-emit. Radiation na absorb. Or kapag Raman, na scattered. Okay? So it's a display of intensity of radiation emitted, absorbed, or scattered by a sample versus what? A quantity related to the energy. Kasi hindi ka naman mag-emit or mag-absorb or mas-scattered kung wala kang input. At yung input na yun ay in the form of energy. Pwedeng, anong form yung energy na ilalagay natin? Wavelength or ano yung isa pa? Gen Chem 2.
Frequency, sir.
Frequency. Okay? So, we could put it like here. Tapos ito yung parang signal na pwedeng ganon, pwedeng ganon, or pwedeng instead na wavelength, pwede mong ipakita frequency na lang. Okay? Tapos, ma-observe mo yung signal na ma-observe ka dyan. So, yan yung usually yung tinatawag nating spectrum. Okay? Yung spectra, pag marami siya. Now, yung spectrochemical, ang explanation dyan or implication yan is this is a spectrum or some aspect of a spectrum that is used to determine the chemical species and to investigate the interaction of the chemical species with the electromagnetic radiation. So, ang dami nating ngayong term about electromagnetic radiation. Okay? So, pag sinabi natin spectrochemical, so we're looking at yung spectrum or a part or aspect of the spectrum that is used to determine the chemical species and to investigate the interaction of the chemical species with electromagnetic radiation. So pwede rin natin sabihin na kapag meron tayong spectrochemical methods, okay, it can involve either a direct optical measurement. So meron pang ibang term dito, optical. So malalaman natin anong ibig sabihin niyan. Okay? So it can be a direct optical measurement of the photons that are emitted or transmitted, or an indirect measurement of a quantity related to the result of the photon absorption. So it's really a matter-light interaction or electromagnetic interaction. Okay? So maybe yung example ng indirect, yung the number of ions or quantities related to the kinetic energy produced by absorption, it can be monitored and plotted as a function of wavelength, okay, to obtain a spectrum. Okay? So we could say yan yung spectrochemical analysis. Now, when we're talking about spectroscopy, ano to? So this is just the science of the interaction between
Matter and light.
okay, the matter and light. So spectroscopy is the science that deals with the interaction of electromagnetic radiation with matter. Okay, so we could say there are several types of interactions that are possible. And many of these involves usually the so-called transition between specific energy or energy states of chemical species and are observed by monitoring either the absorption or emission of electromagnetic radiation. So, meron tayo, I think one of the things that you're going to learn in this course is, what is a Jablonski diagram? Narinig niyo na ba yan? Or, sa 230, hindi niyo narinig?
Yes po, sir. Yes po.
Lahat kayo nag-230 sa akin, hindi niyo narinig yan.
Narinig po pala, sir.
Okay? Kasi yan yung parang summary of all the tinatawag nating spectroscopic methods o yung interaction ng light doon sa matter. Okay? So, it can involve usually this transition between specific energy states of chemical species tsaka yung observe nilang monitoring by absorption or emission of electromagnetic radiation. So usually dito sa type na interaction na to, it's useful to consider the electromagnetic radiation as composed of what? Discrete packets. So parang ang ano dito, hindi siya continuous. It's like a particulate. Yung tinatawag natin photons. Okay? So, ang inaano natin dito ay yung wave character. Okay? So, I mean, we can look first at this particulate character, although we all know that electromagnetic radiation can also have this so-called wave character. Okay? So, we can relate, how can we relate the energy of a photon to its wavelength and frequency? So you have E equals to, you still remember this? What is H?
Planck's constant po, sir.
So Planck constant times the frequency.
Frequency.
Tapos, ano yung alternative ano nito? Form. Pwede natin i-ano tong B or frequency as equals to C over the wavelength. So this become like this one. Okay, so yan yung we could say spectroscopy more on the interaction of matter with light. Now ano naman to? Minsan nakakalito yan sila eh. Spectroscopy, okay? Spectroscopy, spectrochemical analysis, and yung tinatawag natin spectrometry. So if we're going to look at spectrometry, so spectrometry is just more on what? Restrictive yung term na ito. Okay? So if we're going to look at spectrometry, saan siya usually pumapasok? Yung term na spectrometry. It has something to do with what we call the quantitative measurement. Okay? So, pag tinitingnan natin yung spectrometry, it has something to do with quantitative, denotes quantitative measurement of the intensity of electromagnetic radiation at one or more wavelengths. Okay? So kailangan natin ito. Photoelectric detector. So parang nangyari dito, meron na tayong way to measure. Okay? Yung signal na nakukuha natin. So we could say this is more restrictive term than spectroscopy. So spectroscopy kasi, di ba, light matter interaction now lang. But if you're able to put some sort of a measurement doon sa interaction nila, we can say that it is spectrometry. Okay? So yan yung we could say na common term that we usually interchange with regards to kung ano yung idea na yan. Spectroscopy, spectrometry, okay? Tsaka yung tinatawag nating spectrochemical analysis. Okay? Now, we have to look at the types of the radiation and matter interaction. Okay? So maybe the thing that we could look at is reflection, refraction, and diffraction. Okay? So these are, we could say, some of the types that we have. But later on, we will see that meron tayong tinatawag na more interaction, because itong types ng interaction na ito I gave you here, they doesn't involve what we call transitions. Don't involve transition. Because ang nangyari dyan, nagpumasok yung energy doon sa sample and then reflect. So walang absorption or emission, right? So either may reflection, may refraction, may diffraction, or yung tinatawag na scattering. Okay? So this doesn't involve transition. Don't involve. So it doesn't involve transition between energy levels, but rather cause changes in the optical properties . No radiation. So ano ibig sabihin nito? Ano yung optical properties na to? So meron tayong tinatawag na change in the direction or polarization. Okay? So if we're going to look at this interaction, they're often related to the bulk properties of the sample rather than the specific chemical species. So remember, when we do analysis, spectrochemical analysis, we want to be specific. Okay? So this one, usually, hindi sila specific dun sa chemical species. They look on the bulk properties of your sample. So parang yung overall property ng sample. And these several analytical techniques are based on this, what we call bulk interaction. Okay? So this gives us to this term, yung tinatawag na optical spectrochemical analysis. So if we're going to look at this, if we look at spectrochemical analysis in general, yung spectrochemical analysis, it deals with EMR or electromagnetic radiation of an enormous range, usually from the radio frequency to gamma rays. But when we're talking about optical, we become restrictive. So, ito yung range. Why? Okay? It has something to do with the optics. Ang tanong, makikita mo ba yung radio waves or gamma rays if you have an optics? Usually hindi, di ba? So, pag tinatawag natin optical spectrochemical analysis, nire-restrict natin doon sa region na yun. So, we could say the visible region and the region beside it, right? Ultraviolet is at the lower energy end of the visible region. IR is, or I think not lower energy. UV is a higher energy end of the visible or the shorter wavelength. Okay, while the IR is the longer wavelength part, or in the longer wavelength region of the visible and the longer wavelength and the lower energy region. Okay, so dito sa range na to, we have these instrumental requirements that are similar. And the material used for dispersing, focusing, and directing the radiation are either glass, quartz. Kung meron kang IR, yung tinatawag nating alkali halide crystals. Okay? So, quartz, you can use it in UV region. Glass, usually in the visible, together with the plastic. Yung tinatawag natin mga cuvette. Now here, ito yung tinatawag nating mga crystals. Yung nilalagay natin yung mga IR, or if we want, we pelletize, we use the so-called KBR pellets. Ay, naku, maingay na naman. Okay? And we could also say that the optical chemical techniques can either be atomic spectroscopic techniques or molecular. Okay? So if we're dealing with atomic spectroscopy, we deal with the pre-atomic species that are usually in the vapor state. So anong method ang meron dito? Anyone? Nandyan yung AAS, tsaka yung AES. Although I think this is the one that is common compared to this one. Although this is more, we could say sensitive compared to AAS. Okay? So, when you're talking about atomic spectroscopy, so parang ina-atomize natin yung substance. We look at the atomic level. But if you're talking about molecular spectroscopy, so deals with the molecular species in either the vapor state or in solution, or even in the what we call solid state. Now, if you're going to look at the optical spectrochemical analysis, its wavelength is from nanometer, angstrom, or micrometers. Okay, and if you have one energy equivalent to 1 electron volt of photon, that's 1240 nanometers. So that is in the IR region. So if you're going to increase the energy, your wavelength will become shorter. So because the wavelength is inversely proportional to the energy, the wave number is often used. So ang ginagamit natin pagdating na sa IR, we don't use the wavelength. We use the so-called wave number. Usually ganon, di ba? Wave number is just 1 divided by the wavelength. Kaya yung centimeter natin nagiging per centimeter. Okay? So the wave number is the number of cycles per unit, and that's the reciprocal of the wavelength 1 over the wavelength. And the wave number is usually expressed in per centimeter, and it is directly proportional to the energy. So if you're going to look at this, nandito siya. Okay? So it is directly proportional doon sa energy. So we will tackle that when we go to the IR region. So if we're going to look at the energy or the wavelength of the photon that we determines the type or shape of the interaction that occurs, so meron ito dito. So this was obtained from the book. Okay? So meron kang gamma ray, X-ray, yung far UV, near UV. So this is the wavelength that we have. I think I shown this slide last time. Okay, yung nag-introduction tayo. Then you have the visible region, the near IR, the middle or fundamental IR, the far IR. So this is, we could say, yung optical region. And if you're going to look at the transition, so kapag high energy, ang naapektuhan talaga yung tinatawag nating mga core electrons. Okay, compared to the what we call the valence electron. Yung mga low energy, it mostly just affects the so-called molecular vibration. And if you go with the microwave and the radio wave, it's mostly just the rotation o yung tinatawag nating electrospin. Okay? So I'm not sure if you heard the term mga EPR o yung tinatawag na Mossbauer spectroscopy. Okay, so there are some of them that are involved here. So if we're going to look at the nature of the spectrochemical analysis, so maybe we can tackle them in terms of the types of analysis, the sample, the spectrochemical phenomena, and the analysis of the real sample. Okay, so if we're going to look at the types of analysis, so maybe babalik tayo dyan sa common doon sa analytical chem, yung qualitative versus quantity. Okay, so you can use spectrochemical methods either for qualitative or quantitative, either for the identification of species or determination of the amount of a particular species. Yung tinatawag natin what is present and how much is present. So yan yung ila-lecture ko mamaya sa 137. Okay? So qualitative can be considered as a low resolution type of quantitative analysis. It often answer a binary question, yes or no. Yes, it is present. No, it is not present. Okay? And you can continue on if the answer is yes, it is present, to determine how much is present. Pag ang sagot is no, it is not present, so what's the use of doing quantitative analysis? That's why I think it's routinary in any chemical analysis to do qualitative first and then quantitative. Now, we can go back to our analytical chemistry to determine this term, yung minor, major, tsaka trace constituent. Okay, so the constituent determined the spectrochemical analysis can cover a broad concentration range. So in some cases, you can use it to determine the major constituent. So usually, it's the one that is present between 1 to 100%. So kapag minor, it is from 0.01 to 1%. And you can also use it, okay, to those who are present lower than 0.01%, yung tinatawag na trace constituent. Example that we do here is the presence of manganese in steel. We both use there, okay, an atomic spectroscopy and a molecular spectroscopy. So meron kaming AAS at yung sa molecular ay yung absorbance. So manganese is just a trace constituent doon sa steel. Steel is made up mostly of what? Iron metal na dinagdag ng carbon. Okay? But one other metal that they contain, there is what we call the manganese. And then we can also, as I told you, we go back to this term in your analytical. So you can also use spectrochemical analysis doon sa macro analysis, one that you carried out when your sample weighs more than 0.1, yung semi-micro or meso analysis. So that's when you have a sample between 0.01 and 0.1. Tapos meron kayong tinatawag na micro analysis. So that's 10 to the -4 and 10 to the 2 grams. So from 0.0001 to 0.01 gram. O yung tinatawag na ultra micro, which is less than 0.0001. So the term ultra trace analysis is considered to be the determination of trace constituent in an ultra micro sample. So applicable din itong tinatawag nating methods na to. And I think that's the reason why they use in this blood test o yung tinatawag nating urinalysis. Okay, when they try to analyze some of the compounds there that are present in small amount. Okay. And then we can also look at the so-called samples, right? So when we're talking about samples, we have this nomenclature for dealing with the samples used in spectrochemical analysis, and unfortunately, these are usually confusing and contradictory. Okay? So kapag nag-aano tayo ng spectrochemical analysis, so ito yung ibig sabihin ng mga term. Pag sinabi natin initial sample, so it means a portion or subset of the bulk material or population about which analytical information is desired. So for instance, yung liter of water, that's your initial sample. You obtain it from a lake, so that's the bulk material, in order to determine the mercury content. Okay? Now, yung analytical sample naman, it indicates the portion of the initial sample which is presented to the instrument for spectrochemical analysis. Okay? So, hindi lahat ng initial sample mo ma-analyze. Okay? So, yung sample na ma-analyze from your initial sample, ang tawag natin doon, analytical sample. And just like any analysis, okay, sampling is very important. The strength of your chemical analysis lies in the sampling method. Kahit high-end instrument ang gamitin mo, pag yung sampling mo or yung samples mo ay hindi representative sample, your data will just be useless. Okay? So in all cases, you can also do this sample pretreatment. The analytical sample must be representative of the concentration of the sulfur species in the bulk material. Now, errors made in sampling or sample preparation are carried through the entire process and lead directly to errors in the final results. So that's where the importance of sampling come to play. So dapat yung sample mo ay yung tinatawag na representative samples, or else it's going to be useless. I think I have a story there from one of the old people from chemistry when he told us that when he works in to monitor I think some chemicals in volcano. So he asked three workers to have rotation. And then he found out when he visited the site, all of them has already collected the sample when it's supposed to be collected within 24 hours. So ang idea niya, sabi niya, I ask you, okay, the three of you to, ano bang tawag dito, magpalitan kayo para every, if I'm not mistaken, 2 hours, merong sample na napokolect. So yung ginawa nung tatlo, nag-collect na sila para sabihin, ito from alas 12, ito from alas 2, ito from alas 4. So it defeats the purpose. That's something. Kasi ang dapat, so isa, 8-hour shift, tapos after nung isa, another 8-hour shift, tapos yung isa, another 8-hour shift. Pero ang ginawa, nag-collect na sila, nag-sample to represent the thing. Okay? And I think it also happened if you go to the industry. If, ano ba yung dami kasing kwento ng mga kabatchmate ko. He walked out of the scope because he cannot take what the other QA are doing. So parang imbes na every batch ng sample ina-analyze nila, ang ginagawa, meron ng set na no, tapos minsan hindi pa daw ina-analyze, nag-aano sila yung parang chemical dubbing. So parang okay na yan, yan, hindi, without even doing the analysis. Okay? So that's the importance of what we call sampling. And we will encounter terms like analyte. So maybe this is not really new to you. At tapos yung tinatawag natin matrix. Okay? So analyte is the species that we want to determine or the chemical of interest, okay, in a given sample. Now yung matrix, yan yung collection of all constituent in the sample. Okay? So the more materials or other chemicals you're present there, the more we could say complicated or complex your matrix is. Sometimes meron tayong tinatawag na matrix effect. Okay? So anong ibig sabihin ng matrix effect? Yung presence ng ibang constituent doon, it can affect the signal of your analyte. And then you may ask what kind of effect? It can enhance or decrease the signal of your analyte. Tapos meron din tayong tinatawag na term na analytical matrix. So it refers specifically to the matrix of the analytical sample, which may differ from that of the initial sample due to the advantages added or removed of the various sample treatment stages. So remember, you have initial sample versus analytical sample. So alin dyan yung parang mas malinis na? Yung
Analytical sample, sir.
Analytical sample. Yung initial sample, that's what it is. But you seldom have a method that when you analyze it, that is makukuha mo yung anong tawag dito, reading mo or signal. If you doing GC, you analyze your what we call sample as it is, sira agad yung ano mo, instrument mo. Dapat gumagawa ka ng mga clean up. So from your initial sample, it becomes yung tinatawag na analytical samples. But even though, okay, medyo malinis na siya, meron pa rin siyang compound na nandoon. Kaya meron pa rin siyang tinatawag na matrix. But it is much clean or cleaner compared dun sa isa. Okay? And then we can also say that the matrix as defined here, it includes the analyte as well as or other constituents that we can call the concomitants. Okay, you even term it contaminants, but this is what we call concomitants. Okay, so in trace analysis, the analyte is present in such small amount that it is convenient to speak of the analyte and the matrix separately. So for trace analysis, we sometimes think of the matrix as being composed of the concomitants. Okay, in major constituent determination, the analyte is a major part of the matrix. So example, in determining your iron in steel, the analyte, which is the iron, is present in such large amount that it determines the bulk properties of the sample. Now here we could say, wala nang matrix. Okay, yung matrix mo is no longer composed of just the concomitants because that's the major component that you have. So kung meron mang effect yung iba, hindi na as obvious doon. Okay? And then you can also have this chemical speciation. So this is concerned with this determining this concentration of specific chemical form of the analyte. So sa metal, meron kang Fe2+ and Fe3+. Paano mo nalalaman kung Fe3+ yung iron mo? Sige nga. Kung nag-analyze kayo ng iron, pag Fe3+, anong kulay ng sample nyo? Yan ba yung colorless o yung colored ano? You have any experience working with iron? Usually yung Fe3+ siya yung yellow color. Yan yung tinatawag natin the more oxidized form. Okay? So, paano mo maano na, let's say you want to analyze and you want to keep it in Fe2+. What do you need to do? Maybe you have to add some antioxidant there so that your sample will not oxidize. Okay? And unfortunately, our atmosphere contains oxygen. So talagang ma-oxidize minsan yung sample mo. So the only way I think you can keep it is maybe like here, the amount of metal in a particular oxidation state or the amount of a drug bound to a protein, which is Fe2+ and Fe3+. Okay, so the nature of the sample matrix here and the effect or the matrix effect on the determination depends upon the chemical interaction among matrix component and between matrix component and the analyte. So usually, yung ano dito is how, let's say, a specific compound interact doon sa sample mo. I remember one experiment in our analytical chem here, they determined the presence of zinc. So yung ibang student ko, pag zinc lang yung present sa tablet, walang problema. Okay, because they bound it with a complexing material. So kapag meron ng iba like zinc, Fe, or kung ano man ibang other metals doon sa tinatawag natin, alam niyo yung centrum, yung mga multivitamins. So bigla sila, sabi nila, it mentioned here that this is just the amount of zinc, but the endpoint that we get is much greater than the one when we analyze what we call yung zinc or pure zinc tablet. So inano ko lang. And then a semester after, sabi ko, oh, i-present mo ba? Tapos sabi nila, hindi namin na ma-interpret bakit gano'n. Tapos in-explain ko sa kanila because we're already in the instrumental level. So what do you think is the difference between the zinc tablet that is pure and the one that is, let's say, in a multivitamin? So have you ever considered the presence of the other metal there that can cause some matrix effect? Okay? So ganun yung parang epekto dito. So we found out na yung chelating agent na ginagamit namin nag-i-interact din doon sa other species. So if it's just zinc, so there's really no matrix effect. But if it's made up of zinc and other multivitamins, okay, so we could say the chemical effect, matrix effect there is much higher. So the chemical forms of the analyte and the matrix component is really, we could say, critical. Okay? So yan yung tinatawag nating sample because we look at this, the type of analysis and then the samples. Now we look at the spectrochemical phenomena. So ito na yun ngayon kung ano yung mga interaction. So as you see here, to obtain the spectroscopic information about the chemical samples, the species to be determined is usually stimulated in some way by the application of energy in the form of heat, electrical energy, radiation, particles, or chemical reaction. Okay? So this is simply the source of your EMR. EMR is really energy. Okay? So several spectroscopic phenomena depend on transition between your energy states of particular chemical species. So maybe papasok pa din dito yung concept nung matawag doon. Yung state, excited state, tsaka ano yung isa? Sa Gen Chem natin?
Ground stage, sir.
Ground state. Yeah, yun. Thank you. So parang papasok pa rin dyan. Pero ang ano lang nga natin dito, yung tinatawag na energy state, yung parang energy level state. Because some spectroscopic phenomena depends on the so-called transition between energy state of particular chemical species. So prior to the application, nandito pala, ground state of external energy, the analyte is open in the ground state, yung lowest energy form niya. And then when you apply the energy, it causes the analyte to be momentarily in a higher state or excited state. Diba yung kanta, I'm so excited. Pero ang problema nga, the excited state is not usually stable. So the tendency for that is to go down. So you can get information on that. Okay, so spectrochemical information provided by measuring the EMR emitted by the species returns to the ground state from an excited level or by measuring the amount of the EMR absorbed in the excitation process. So if you go up, that's absorption. When you go down from excited to ground state, that's emission. Now, other spectroscopic techniques depend on the changes in the optical properties of EMR that occurs when it interacts with the sample or analyte, or in photon-induced changes in chemical form, like ionization or photochemical reaction. So dito, ito yung case kung bakit sa ibang spectroscopic group, pasok yung mass spec. Yung tinatawag na ionization. Okay? So if we're going to look at this, so these are some of the types of what we call optical interaction. Okay? So tingnan natin dito sa A. So what can we say about what's happening here in A? Wala external radiation, di ba? Because if you're going to look at this, the arrow is going out. So this is, we could say, emission or chemiluminescence. Yeah? In the absence of the electromagnetic radiation or external radiation source, the analyte can be excited by maybe collisional process or chemical reaction. And the resulting emission and chemiluminescence will happen. Right? Kapag biological in nature, kagaya nung, ano bang tawag doon? Firefly? Ano yung firefly sa Tagalog? Yung nailaw? Kalimutan ko na. Hindi, alitap-tap yun.
Sir, alitap-tap nga.
Alitap-tap ba yun? Yung nailaw? Okay.
Aba.
Basta alam ko firefly yun. Nakikita pa rin namin dito sa US eh. Pero hindi na, alitap-tap. Okay, so that is a bioluminescence phenomenon. But if you have a chemiluminescence, okay, ito yung, ano ba yun? Napanood ko lang sa CSI, luminol. Okay, so luminol is usually emit, okay, luminescence by chemical reaction. Now, if you're going to look at this one, so on its own, now yung letter B naman, ang tawag dito is either what? Refraction or reflection. So what happened here? So ito yung sample mo. Okay? So meron kang radiation beam from an external source, tapos it is directed into the samples. So what happened here? Interactions such as refraction and reflection cause a change in the direction of the beam of the sample interference. Okay? Ang mas ano dito, I would say is this one, the reflection one. Because I remember our AAS, no, not the AAS, yung UVBs namin, sabi sa amin, oh, you can have a reflectance there. Kaso hindi sa amin tinuro kung paano gamitin yung reflectance. So in addition daw sa absorbance, pwede namin kunin yung reflectance ng sample namin. So it's just based on the interaction that you have there of this radiation beam going to your sample. Now, yung last part na meron tayo dito, okay, ito yung tinatawag nating radiation that can either be what? Absorb, transmit, or scattered. Okay? Meron pa nga tayong tinatawag nating photoluminescence yan. Because photoluminescence is a result when you put an energy source or radiation source to a given samples. Okay? And it emits something. Okay? So these are just some type of what we call interaction. Now, after this, we look at the optical transition. Okay? Or before we go that, we can also discuss some of the term that we can use here. So we could look at the emission, So we could say this is just what? The term emission, the process of a photon being emitted. Okay? And usually, meron tayong tinatawag na emission spectroscopy. So it usually refers to the spectral information that results from non-radiational activation process or processes. And you will know about it when we go to fluorescence. Okay? So the emission that results from species excited by chemical reactions, that's what we call the chemiluminescence. So if we're going to look at the thing that happened here, so the refraction and what we call the reflection. So these are phenomena that could happen when the sample is exposed to an external source. So when we say reflection and scattering, these are optical phenomena resulting from a change in direction of the incident photon. Okay, so we can say reflection and yung tinatawag natin elastic light scattering. Okay, they do not involve a change in the frequency of the incident photon. But the scattering can lead you to the so-called Raman, yung elastic thing. It involved inelastic scattering in which the change of energy of the scattered photon is related to the molecular energy levels. Now, yung absorption naman, yung incident photons by the analyte, it promotes the analyte to an excited state. And this results in what? Reduction in the intensity of the electromagnetic radiation that is transmitted by the sample. Right? Kapag 100% transmission, anong absorbance nyo?
Zero, sir.
Zero. Okay? So kapag less yung transmission, less than 100%, that means some of them was absorbed by your sample. Okay? And in the absorption process, yung species na excite ng absorption, they can lose the excess energy by radiational or non-radiational process. Okay? With the latter leading to an increase in the kinetic energy of the sample. So meron tayong radiational versus non-radiational. So when you say a radiational deactivation process, this can result in emission of photons, and the emission of photons from excited states produced by radiational activation like absorption. That's called photoluminescence. Now yung fluorescence at phosphorescence, these are types of photoluminescence. Okay? And they're only applicable for those samples that fluoresce or phosphoresce. So hindi lahat ng sample nag-fluoresce or nag-phosphoresce. Okay? And you will know about that when we go to fluorescence. Okay? And then we also have this term luminescence. So luminescence refers to emission from cool bodies or to emission from hot bodies that is not due to thermal excitation. So nag-occur lang siya. Okay? So that's in this context, nandiyan yung chemiluminescence of a molecules in solution together with molecular fluorescence and phosphorescence. So tingnan natin ngayon yung interaction. Tingnan natin, ano kaya nangyayari dito sa first one? Anong basis nito? Based dito sa diniscuss natin. So makikita mo, meron kang excitation and then mostly dito. So this is just
Emission, sir.
emission. This is just this. Okay? So the basis of emission and chemiluminescence, we could say, is described by this one. So this is the energy level. So ground state going to excited state. So we could say E0, E1. So as you could see here, must emphasize yung papunta from the excited state to the ground state. Now letter B is what? This is just
Absorption.
absorption. Now just try to remember, not all samples can do A, but we could say most of the samples can have B. Okay? How about C? So, parang katulad siya ng A at B pag kinombine, right? Tingnan mo, meron kang dark line dito, tapos unfortunately, yung pagkakaiba lang yung isa dito, maybe radiation-less, and the other one is non-radiating. So we could say this is what? An emission of a photon following radiative excitation. So ito yung pagkakaiba nitong full line compare dito sa dash line. So merong radiative excitation. So we could say this is your photoluminescence. So yan yung Jablonski diagram nyo. pag pinagano nyo yung big picture, maano dyan sa yung Jablonski diagram. Okay? So, pag nakita ninyo dito yung dash line, okay, at yung arrow, it indicates that the excited state can also lose its energy by non-radiative. Yun yung dash line. Now D. What do you think is D? There's an excitation and emission, but it's not really an emission. You could see here, meron kang dalawang arrow. Tapos yung isa meron dito. And the thing is, this is not an energy level. This is what we call a vibrational state. Okay? So the excitation or deactivation can involve a combination of radiative and non-radiative transition in which the wavelength of the emitted photon can be less. So yan yung tinatawag nating stocks, tsaka yung anti-stocks.
Scattering po ba?
Okay, so it is a
Sir
scattering. Okay, so specifically it's both for this and this, D and E. So that's the scattering, and this is the basis of your Raman. The absorption here, this is the basis of your UVBs, and what else? IR. Okay. Now, letter F here still similar to this one. Ang pagkakaiba lang, yung species natin dito, it undergoes a non-radiative kasi dash line. Okay, the activation to a lower excited level before the photoemission occurs. So yan lang yung anuhin natin, this what we call thing. Well, mostly most of these are either atomic or molecular. But when we're talking about atomic, ito lang yung dalawang yun. Okay, wala tayong atomic fluorescence. Usually we have the fluorescence is mostly a molecular thing. So question, kasi ito lang yung parang interaction na makikita natin sa spectroscopy. And if you're going to look at it as a big picture, yan yung Jablonski diagram. You will see it when we go in each of these what we call the method. So question dito sa phenomena, sa spectrochemical phenomena, before we go to the...
Sir, ito pong F ay Raman din po, bale.
Parang Raman din yan. Pero ang common dito sa dalawa ito.
Okay po.
Kasi ito parang yung meron siyang radiation non-radiative analysis. Okay.
Okay.
So let's look on analyzing real samples. Okay. So we all know the analyte is always present as part of the sample matrix. And then the concomitant species in the matrix can undergo the same spectrochemical processes. So the thing is, if you have a complicated sample, it will also interact, okay, with the electromagnetic radiation or whatever source of energy that you put on the matter. Okay, so the presence of these other species in your sample or in the matrix, it can really affect, okay, the analysis. So the concomitant species in the matrix can undergo the same spectrochemical process as the analyte, or they can affect the ability of the analyte species to undergo the desired process. So yung presence nun affect the ability to observe or measure the optical interaction of the analytes. And all of these effects due to the concomitants can give rise to this what we call matrix effect. Now you can ask, ano ba yung sources ng concomitant species? So it could be the reagents or solvents that is used to treat the samples prior to analysis. Ano usually ang ginagawa natin? Usually, we could have this what we call blank subtracted, right? And we could say blank is not always water. Okay, it's usually whatever solvent that you use. And then other source of what we call concomitant species, yung contamination during sample acquisition, storage, and preparation step. Now, all of this can interfere by other means, such as the chemical reactions with the analyte species. Now, the question is, how does we can make the emission, absorption, and luminescence methods more specific? Okay, so maybe we have to look at the wavelength or the frequency that we use. Even though we could say all samples will interact with light sources, but the interactions that they have is selective. Okay, so some of them are selective at a certain wavelength. So maybe by that way we can make the methods, the spectrochemical methods that we have more selective by looking at ano ba yung frequency or wavelength nag-i-interact yung analyte natin. Okay, so what we can do when we have this optical information concerning the analyte, we can always determine or distinguish from the information from the concomitants by using instrumentation that allows specific wavelengths. So let's say if you have metal samples doon sa water. So if you analyze AAS, each metal has its own specific wavelength. So at that wavelength, excuse me, makukuha mo lang kung ano yung specific metal, unless may metal ka rin na present doon na hindi yung analyte na ina-analyze mo na katulad yung wavelength, and that can be a problem. Okay, but at least you're able to reduce the effect of this concomitant. You were able to make your method more selective. Okay. Now, selectivity can also be enhanced by using other optical property. Okay. So for instance, I'm not sure if you're familiar with polarization. So parang inaano mo lang yung light, minamanipulate mo lang Okay, so in conjunction with the intensity and the wavelength information, okay, you can use polarization or by employing selective chemical reactions. So maybe in this chemical reaction, you can remove the concomitant. They will react there, leaving you with your analyte. Okay, so the way that we do it here to improve the selectivity, we will follow the accepted conventions that samples are analyzed, but that concentration or species are determined. So you analyze the sample, okay, but you determine the concentration or species. Thus, we can properly speak of the analysis, let's say, of paint or lead, or determination of lead in paint. So what does it mean? Okay, it is incorrect to speak of the analysis of lead in paint. So hindi daw tama yung pagsabi mo analysis of lead in paint. Okay, so it's either analysis of paint for lead or determination of lead in paint. So analysis of paint for lead levels, hindi yung analysis of lead in paint. So yan yung ibig sabihin ng statement na yan. Okay? So we talk about blank. So yung ideal blank mo, it contains all the sample constituent except the analyte. I remember my main professor here. How do you define blank? So yung definition niya, everything except the analyte. So blank is everything except the analyte. So that's the signal between your sample and your blank is just due to the analyte. Okay? So in practice, the blank is treated as much possible identically to the sample as possible. So kapag nilagyan mo ng acid yung sample, so yung blank mo dapat may ganun din. Okay? The thing that you have here, the instrumental response from the blank is then subtracted from that of the sample in order to compensate for the effects of the concomitants. So an ideal blank can eliminate some types of interference effects due to the concomitants, but cannot compensate for concomitant species that affect the production and measurement of the analyte response. Now, the problem is it's difficult to prepare an ideal blank, okay? Because you don't know what are the other species that you have in the sample, okay? You don't know the concentrations that you have here. So the more desirable approach is to arrange measurement conditions to minimize the response due to the concomitants. So what's the best way that you usually do? Yung blank subtraction. Okay? So pag meron kang nakikita, oh, meron tong sample na ganito. So pwede mong sabihin, so can you have a sample like that? Or the way that they do is maybe you spike it, okay, with known concentration. Tapos kukunin mo lang din yung signal ng standard na iginamit mo. So meron kang blank, tapos yung spike sample mo, tapos yung standard mo. And you try to determine how much is the amount in your sample. Okay, so it's really hard. Okay, I remember when we analyzed this SHIT. If you what we call watch Dr. Aga's talk last time. So we always have matrix effect. Okay, And we cannot usually have blank doon sa tinatawag namin environmental samples. Okay? And we also have to take into consideration yung containers. So it's actual analysis is complicated because the sample is almost always confined during measurement by a container, except for few in situ measurements. So in molecular spectroscopy, you have the glass, the quartz, or yung tinatawag nating salt cell. Okay? And optical interactions with the container can give rise to additional interference effect. Now, if you're doing AAS or atomic spectroscopy, you can either have a flame, a plasma, or a heated chambers. And this can emit or absorb radiation which can interfere in your results. So in some cases, the sample matrix can alter the interference effect of the container. Okay? So siguro I'll end this thing here because the next one is some sort of the expressions of analytical information. So question. So itutuloy natin dito. And then next meeting, we will proceed with the chemical measurements. So we will try to work maybe some until midterm yung book nitong kay Ingel. Okay? So tanong.
None so far, sir. Wala pa naman po.
May natuto ba kayo? May natutunan kayo?
Yes po, sir. Bago po sa akin yung concomitants.
Kasi ang ano ko nga this is just more on a review but a much in-depth ano doon sa method of spectroscopy. So maybe some of the term is not new to you because they were tackled maybe in Chem 137 if you are UPLB or whatever instrumental method of analysis that you have. Okay? So ang first ano nga natin dito yung general ano muna ng spectroscopy. Tapos, ang next tackle natin ay yung specific method. So, we go with the UVBs, we go with the fluorescence, IR. So ganun yung magiging ano natin for the meeting. Okay? Hindi ko pa nga naaano yung syllabus, but I think, ano gusto nyo? Quiz or problem set?
Sir, may question pala ako, sir.
Yeah, okay.
Yung sa blank po kasi, medyo nalilito po ako dun sa ano kahit tinuturo ko na siya, nalilito pa rin ako. Yung sa reagent blank, method blank, ganyan.
Field blank.
Yan. Iba-iba po sila, di ba? Yes, sir. Hindi ko po sure kung i-discuss pa po siya sa mga susunod na session or...
No, hindi na. Kasi ang ano nga, sabi ko nga sa iyo, when you're talking about blank, yung talagang pinaka-ano ng blank is everything except the analyte. Pero ang problema, hindi natin na-achieve yan. So let's say, meron kang soil sample. So, maraming blank yun. So kapag kumuha ka ng soil sample mo, i-analyze mo, tapos kumuha ka rin ng parang soil sample mo sa blank, anong tawag doon? Field blank, di ba? Tapos, meron ka rin yung tinatawag na reagent blank. So pag inano mo yung sample mo kung ano man yung reagent mo, so gusto mo rin i-ano doon sa blank mo kung ano yun. So yun yung reagent blank. So there's a lot of what we call definition doon sa blank. Okay? But it's just the way how you treat your blank. Because it's so hard to achieve na yung tinatawag nating ideal blank. Yung ideal blank is everything except the analyte. But the more complicated the matrix of your sample, the more complicated your blank will be. Naintindihan ko yung ano mo, yung hard way to determine them. So the way I do is I just go with the convention kung ano yung definition. But you can always tell your students that the ideal blank that you have is everything except the analyte. Kasi ang ano nga doon, gusto mo makita na yung signal na nakukuha mo is exclusive from the analyte. Yeah. Pero ang problema, sabi nga yun, the more complicated it, just like in real life, the more complicated the analysis is. So ano, quiz na lang? Yung quiz yung magdi-determine kung sino yung A, 1, 1, 2, 5, 1, 5. Ano, decide kayong tatlo. Wala naman magawa yung isa eh.
Pag quiz, sa canvas lang po siya, no?
Oo.
Tapos pag problem set, yung para mag-essay kami. So,
Ano pa kayo, yung exam niyo, magse-search na kayo. Pag mag-problem set, additional time pa kayo mag-ano. So pag quiz, I will make the material available naman, yung recording tsaka yung PowerPoint slide. So all you need to do is maybe look at it. So, pero baka true or false lang yung sasagot i-question ko eh. Para at least makikita ko kung maintindihan nyo. Hindi eh. Kasi kapag kita nyo lang to, yun. Yun yung parang advantage, disadvantage. Because your exams will really require you to look. You're going to utilize time to look for the answers. So pag problem set, ganun din yun. So pag quiz, maybe 10 minutes or ano lang kayo doon. All you need to do is maintain the perfect kayo para ma-maintain nyo yung 1. So every time sumep lang kayo, parang bababa yung score nyo. Ganun yung ginagawa ko sa 137 eh. So, quiz na lang. Next week pa naman tayo magsisimula. But we might meet every meeting unless may webinar. Oh, very good. You should be sleeping. It's 10:20 already. Kinukulit ng anak ko. Kasi yung next webinar.
Within the day po yung quiz.
Ha?
Within the day lang po siya.
Hindi. Kasi ang problema yung kasama yung isa eh. So parang a certain yung days. Ano lang siya, weekend lang siya pwede? So siguro gawin natin every week may quiz tayo, pero let's say from after class until Sunday para makakuha yung isa. Because you had to watch the video also. Para at least maano siya. Hindi ko pa na-upload yung video last time eh. Pero pwede yatang i-upload sa Canvas yung video, right?
Pwede po, sir. Ililink.
Directly. Para hindi ko na Kasi after nito, let's say, pagkalabas natin, so mag-aantay ko mag-record. Tapos darating yung next class ko. Pagkatapos ng class nun, antay ko mag-record. So hindi pa ako makakatulog kasi antay ko siya matapos. Jeff, question.
Yung quiz, sir, parang per topic lang siya. Short coverage lang. Okay.
Kung ano yung natapos natin within that week, yun lang yung cover niya.
Okay pa. So at least iba pa siya entirely sa exam mismo. Okay, thank you po.
Yung exam talagang gusto ko pakita eh, pero nandun pa yung sagot ko eh. Kasi mag-aano kayo because some of them might not, we might not cover it, pero part siya ng spectroscopy. Yung parang, ang topic kasi like laser, mode locking, amplifier, yung parang ganun. So parang mag-aano talaga kayo doon. Kaya nga ibibigay as early as para masimulan nyo na. So, tanong, question, before we call it a day. Pero we try to meet every meeting. Yun yung ko. Unless ito lang masasabi ko sa inyo, kapag wait na lang kayo dun sa message, kapag sabi ko, muna tayo na ito, ibig sabihin, pagod ako because Thursday is my worst day dito. I have a class from 12 to 2 and then a lab to 2:30 to 5:30. So usually, pagdating dito, ihiga muna ako and as of now, I start at 9, but after March 13, I will start at 10 yung magmamatch na yung time, yung pareho yung time, ang pagkakaiba, AM sa inyo, PM sa amin nito. Right now, you're ahead by, 13 hours? Because right now, it's 11:25 there, kami 10:25 pala. Pero by March 13, magmamatch na yung namin, natin yung time. 12 hours ahead pa rin kayo. So, ibig sabihin, alauna na ako matatapos yun sa classic ko. Right now, 12:00 tapos na ako. Because I remember last spring, pagdating ng alauna, yung Chem 17 ba yun? Talagang inaantok na ako. Habang nagkaklase na ako. Tapos, hindi nakikinig yung mga bata. Napapagalita, parang napipikit na ako, tapos hindi pa sila nagre-respond. Walo lang, out of 20 students, 8 lang yung uma-attend. Kaya I think 137, meron na akong recorded from last semester. So, mag-meet ko lang sila. May tanong ba kayo doon sa record? Tayo, kailangan natin mag-meet. Kasi wala akong recording. At ayaw ko mag-record. So, yung meeting natin dito, yun na yung record. Kasi magre-record tayo, tapos mag-meet. Sabi ko, i-record na lang habang nag-meet tayo. I think mas better pa. Okay? So, try to see if you can find wala siyang bagong version yung tong Ingel. Okay? Sabi nga ni yung yung boss ko dito, si Dr. Desamero. Yan yung Bible. So, any what we call Spectrochemical Analysis, they utilize it. And I think Ma'am Daang, when it was last offered, isa ito doon sa ginamit niya. Tapos sabi nga nung boss ko, kung gusto mo bago-bago, yung bagong version ng Fabia. Tapos nung tinignan, meron pala. Nandoon sa bago to, pero hindi ko pa nababasa ngayon. Tapos nakita ko, parang more on calculation. Tapos may isa pa nga doon, mostly calculation talaga. Yung parang, ewan ko, alam niyo yung mga harmonic oscillator? Narinig niyo yung term na harmonic oscillator? So, it's mostly on Chem. Yung parang, yung time namin si Sir EJ, I don't know kung sino na yun sa ngayon nag-ano dyan. So, sabi ko, hindi ko kayata kayang turuan to. Kasi masyadong yung Chem. Okay? So, doon lang tayo from the analytical perspective. Kasi pwede kasing organic chemistry perspective, like in UPLB, yung IR, okay, meron akong way ng pagtuturo ko, pero meron ding way yung organic chemistry under Dr. Completo na way ng pagtuturo niya, na magkaiba yung approach. Okay? So, ganun yung parang magiging natin. But the thing that I'm hoping is you can learn, especially doon sa nagtuturo ng 137, okay, at 32, because this is the basis that you have there. Okay? So, tanong,